Hey guys, welcome to my lecture. In the last lecture, we spoke about a brief history of Kubernetes, and also we spoke about the typical features of Kubernetes, which make it so widely prevalent and widely well known. In this class, we would be talking about a few more things about Kubernetes. So Kubernetes is an open source container management platform designed to run enterprise class cloud enabled and web scalable IT workloads. It is built upon the foundation laid by Google based on 15 years of experience in running containerized application. Though their popularity is mostly recent trend, the concept of container has existed for over a decade. Mainstream Unix-based operating systems such as Solaris, FreeBSD, and Linux had built-in support for containers, but it was Docker that truly democratized containers by making them manageable and accessible to both the development and IT operations team. Docker has demonstrated that containerization can drive the scalability and portability of application. Developers and IT operations are turning to containers for packaging code and dependencies written in a variety of language. Containers are also playing a crucial role in DevOps processes. They have become an integral part of build automation and continuous integration and continuous deployment pipelines. The interest in containers led to the formation of the Open Container Initiative to define the standard of container runtime and image formats. The industry is also witnessing various implementation of containers such as LXD by Canonical, by CoreOS, Windows Container by Microsoft, CRIO being reviewed through the Kubernetes Incubator and vSphere integrated containers by VMware. Containers orchestration has influenced traditional platform as a service PaaS architecture by providing an open and efficient model for packaging, deployment, isolation, service discovery, scaling, and rolling upgrades. Most mainstream PaaS solutions have embraced containers, and there are new PaaS implementations that are built on top of containers, orchestration, and management platforms. Customers have the choice of either deploying core container orchestration tools that are more aligned with the IT operation or PaaS implementation that targets developers. As you can see in the figure, you can see a typical representation of container orchestration engine. Okay, so the key takeaway is that the container orchestration has impacted every aspect of modern software development and deployment. Kubernetes will play a crucial role in driving the adoption of containers in both enterprise and emerging startups. Now let's take a moment and let's talk about Kubernetes architecture. Coming on to Kubernetes architecture,